So now today's topic is innovative teaching methods. If we talk about teaching methods, so education in the 21st century is no longer confined to traditional chalk and board teaching with rapid advancements in technology. There are some changing learning needs and diverse student backgrounds. Educators are now adopting innovative teaching methods to make learning more interactive, engaging, and effective. So, innovative teaching goes beyond rote memorization and passive listening. It focuses on student centered learning, creativity, problem solving, and collaboration. So, it combines modern tools like digital platforms, multimedia resources, and experimental activities with modern tools like digital platforms, multimedia resources, and experimental activities with proven pedagogical strategies to enhance knowledge retention and real world application. So, the goal of innovative teaching method is to stimulate critical and creative thinking, encourage active participation and collaboration, bridge the gap between theoretical knowledge and practical skills, adapt teaching to different learning styles and needs. So, by embracing innovation, teachers transform classrooms into dynamic learning environments that prepare students not only for academic success but also for future challenges in a rapidly evolving world. And it's a need for modern teaching learning methods, just like a changing learner profile. And today's students are digital natives and comfortable with technology and interactive tools. So that traditional lectures no longer fully engage their attention, shift from teacher centered to learner centered education. So modern methods encourage active participation and it's a instead of passive listening, students become co-creators of knowledge rather than just receivers. So focus on 21st century skills, critical thinking, creativity, collaboration, and communication are essential for future careers. Innovative methods help students apply knowledge in real life contexts, just like there are multiple uh, learning styles, like introduction to innovative teaching methods. You know, in a education in the 21st century is no longer confined to traditional chalk and board. So it's a embracing innovation, and teachers transform classrooms into dynamic learning environments that prepare students not only for academic success but also for future challenges in a rapidly evolving world. Every student learns differently: visual, auditory, reading, writing, or blended learning, gamifications, experimental methods. So these diverse needs and integration of technology, digital platforms like smart classrooms, online simulations, and virtual labs make learning more effective, extends learning beyond the classroom through online content and MOOCs. Just like uh, just like a flipped classrooms, there are students watch recorded lectures in a flipped classrooms where students watch recorded lectures at home and spend classroom time in discussions, problem solving, or project work. So, relevance in NIP 2020 and global context in detail, uh, we can also use a flipped classroom where students watch recorded lectures, just like in these days, just like we also use Swayam NPTEL classes. There is also a online, and we have all lectures, recorded lectures. So relevance in NAP 2020 and global classrooms we talk about. So it's a holistic and multidisciplinary learning. NAP 2020 stresses innovative teaching case studies, experimental learning, project-based learning instead of uh, rote memorization. Technology integration or encourages digital classrooms, online platforms just like Swayam, MOOCs, and virtual labs to modernize teaching. Skill development and employability focuses on 21st century skills like critical thinking, creativity, communication, and problem solving. So, choice based credit system, multiple entry and exit options, and interdisciplinary courses encourage innovative approaches. So, NAP emphasizes continuous professional development of teachers to adopt modern teaching methods. Like NAP 2020 promotes blended learning. It's a mix of online and offline to reach diverse learners across India. In global context, UN Sustainable Development Goal for quality education calls for inclusive, equitable, and innovative teaching methods worldwide. So, global competitiveness countries are adopting technology driven student centered methods to prepare graduates for the global job market. Through international best practices, innovative methods, flipped classrooms, gamification, AI in education, VR and AR labs are now global standards. So, adaptability in a changing world, pandemic and digital revolution proved the importance of online learning and flexible teaching strategies. Collaboration and research innovation teaching enhances opportunities for global collaborations, exchange programs, and classroom cross cultural learning. So many universities worldwide use MOOCs and hybrid models, and NEP 2020 aligns Indian higher education with these practices. But just like if you talk about just like explore innovative methods, pedagogy, what students do. Flipped classroom, short pre-class videos, readings, in class problem solving, debates, labs, used when content is explainable in micro lectures. Project and problem based learning tackle real client industry problems and teams. Deliver a prototype and report based application and teamwork. Case and simulation learning analyze authentic scenarios, run simulations, digital or paper based. Great for management, health engineering, and students vote and discuss, then re-vote. Teacher facilities boost conceptual change. Just like a gamification, serious games, points, levels, badges, guess game based labs used for motivation and practice loops. Collaborative structures, think, pair, share, jigsaw, gallery walks, fishbowl, maximizes participation, and experimental service learning, field work, internships, community projects with reflection, connects theory to society, and design thinking and hackathons emphasize, define, ideate, prototype, test cycles, stimulates creativity. Micro learning plus retrieval practices, 5 to 10 minutes chunks, spaced quizzes, flashcards, improves retention. So, personalized and adaptive learning must be passed with data driven feedback supports visual varied pace, just like blended and high flags. Choice of in person, live, online, or recorded increases access, competency based, clear outcomes, rubrics, resubmission until mastery aligns with employability. AI assisted learning, draft feedback, code hints, language support, teach citation, and verification. So MOOCs SWAYAM curate free high quality content and digital portfolios and reflective journals, showcase artifacts and monthly reflections. So assessment innovations, low stakes formative checks, polls, exit tickets, 1 minute papers, authentic assessments, capstones, client deliverables, performances, peer self assessment with rubrics, and build evaluative judgment. Just like identify benefits and challenges. So benefits are just like higher engagement and deeper learning, active participation, better knowledge reactions, retrieval and spacing, and 21st century skills, problem solving, collaboration, communication, creativity, personalization, and flexibility blended high flex adaptive tools. So faster data informed feedback analytics from LMS quizzes, and stronger employability via authentic portfolio and worthy work. So infrastructure and bandwidth provide mobile first, low data options, downloadable, and PDFs offline tasks. Faculty workload design time start with one method use OER, team teach, template, rubrics, and resistance to change. Faculty and students explain why, show exemplars, run micro pilots, celebrate wins, and assessment, alignment, and academic integrity. Use authentic tasks, oral defenses, version submissions, and open book design. So digital divide and accessibility, universal design for learning, captions, alter, text, high construct, multiple formats, divide sharing strategies. So introduction to innovative teaching methods, education in the 21st century is no longer confined to traditional chalk and board teaching. So it's a different, and there are different types of required best practices, just like draft and alignment. Start from learning outcomes, pick the method that best evidences them. Constructive alignment, map each activity to an assessment and a rubric, share examples. uh, Adopt one and two methods per course in the first term, just like a flipped plus PBL, and use the simplest tool that accomplishes the job. Always have a low tech fallback. So apply UDL, multiple means of engagement, choice of topics, representation, and action. Ensure captions, readable fonts, all text, and color safe slides. So just like explore different innovative methods, flip plus PBL, case plus gamification, experimental and design thinking, blended and high flex adaptive paths, and authentic assessment e-portfolios. Just like engagement, retention, skills feedback, barriers in for time alignment, access integrity, and mitigate with UDL low tech options, clear rubrics, AI ethics policy. So start from outcomes and keep it simple. Teacher centered and versus learner centered. Teacher centered versus learner centered is teacher centered in a instructor is the primary source of knowledge. Become learning is largely a transmission model, lecture and direct instruction. Learner centered students actively construct knowledge. Teacher is facilitator, coach, emphasis is on inquiry, collaboration, and ownership. So classroom examples and activities, teacher centered, lecture with note taking, teacher led demonstrations, whole class recitation. And learner centered, project based learning, inquiry labs, flipped classroom, seminars, student presentations, peer instruction. So, teacher role shifts from deliver to designer plus coach, and assessments move from recall tasks to authentic assessments, projects, portfolios, presentations, and formative checks. So there are pitfalls and mitigations. Pitfall learner centered can be noisy, unstructured, mitigate with clear scaffolds, rubrics, learning contracts. And before large classes train, facilitations use peer instruction, breakout groups, and TA support. So visual idea was just like a passive versus active listening. Passive versus active listening, passive learning and active learning. Passive learning students receive information with little mental engagement, listening, reading without interaction. And active learning, students engage cognitively and behaviorally, discussing, solving, creating, and teaching others. So Active learning increases comprehension, retention, and higher order thinking, and encourages metacognition. And students reflect on how they learn. Teacher role and assessment. Teacher designs frequent low stakes formative activities that reveal misconceptions. Use in the class quizzes, rapid feedback, short reflective tasks, summative tasks still needed for mastery evidence. One size versus personalized. One size, standardized or personalized. Same content, pace, and assessment for all learners. And personalized instruction adapts to learners' prior knowledge, pace, interests, and needs differentiation, adaptive task, competency paths, etc. So, one size uniform syllabus, same assignments, fixed deadlines, personalized adaptive quizzes, tied assignments, choice boards, independent study paths, mastery based resummation, and differentiated groupings. So, personalized learning increases motivation, closes gaps, support diverse learners, and allows faster progress for advanced students. Better alignment with real needs and supports inclusion and equity when implemented carefully. Teacher role and assessment. Teacher becomes diagnosticism and curator. Use diagnostics, pre-test learning analytics to create individual paths. Assessment shifts to competency rubrics, progress trackers, and personalized feedback. So pitfall, perceived unfairness. It paths differ, communicate learning goals clearly, and use transparent rubrics. So pitfall, perceived unfairness. It paths differ and communicate learning goals clearly and use transparent rubrics. So higher workload, leverage adaptive peer mentoring and modular resources, and prioritize which elements to personalized. Suppose we can also use the quick classroom activities, and you can add tomorrow practical. Teacher and learner shift. Replace one lecture with a 15-minute macro lecture plus 30-minute PBL. Starter where students define the problem. Passive and active flip. After a short video, run a 5-minute think, pair, share, and 1-minute paper capturing the midest point. And one size personalized system. Give a 3 tiered assignment: basic, proficient, advanced. Students choose tier and justified choice. So from instructor as talker to facilitator of inquiry, use PBL, flipped classroom, peer instruction, assess via projects and rubrics. Passive, active, and one size personalized. Move from listening to doing. Think, pair, share, and simulations in class, problem solving, frequent formative checks, and reflection. And one size personalized from uniform pace to differentiated adaptive paths. Use diagnostics, choice boards, competency rubrics, scale with tech and peer support. And let's break down the 2 points from your slide in detail. So you can use them as speaker notes or just like a perfect. It's a if you are a teacher, then focus on outcomes, not just inputs. Traditional education often emphasizes inputs such as hours of lectures, number of assignments, or syllabus coverage. So innovative education focuses on learning outcomes, what students are actually able to know, do, and demonstrate after completing a course. Outcomes are measurable skills, competencies, not just completion of activities. Emphasizes quality of learning rather than quantity of teaching. Encourages teachers to design learning with the end goal in mind, and shifts responsibility from teacher taught to student learned. So, input 40 hours of classroom lectures on computer programming. Outcome, students can design code and debug a working program using Python, etc. So aligning curriculum, teaching, and assessment, meaning curriculum design, teaching methods, and assessment should be connected and consistent. This is called constructive alignment. Learning outcomes teaching activities and assessments must all point in the same direction. Curriculum defines what students should learn, outcomes, and competencies. So, teaching learning methods define how students will learn, projects, case studies, blended learning, etc. And assessment defines how we measure learning task portfolios, presentations, real world projects. Misalignment leads to conclusion. For example, teaching critical thinking but assessing only memorization. Curriculum goal, develop problem solving and teamwork skills. Teaching method, collaborative project work. Assessment, group project, presentation plus peer evaluation. Nice. So smart classroom, what it is? Physical classroom upgraded with interactive AV, connectivity devices and software. So teaching becomes synchronous and interactive and data informed. So interactive display and smart board or large touch screen, high quality audio video camera for recording streaming hybrid classes. So reliable high speed Wi-Fi and device charging management, student response systems, clickers, mobile polling, and classroom management software. Integration with LMS and video conference tools, optional AV, AR, and VR station. Document camera, sensor driven controls, lighting camera, auto track, etc. So classroom examples, flipped lesson, students view micro lectures at home, class time used for labs and coaching, and live polling plus think pair share using students' phones. Stand analytics shows misconceptions, hybrid delivery, remote students join live, and recorded lecture available later. There are some benefits of this, just like a higher engagement and interactivity, immediate formative feedback and analytics, and supports blended high flex teaching and recorded revision. Better access to multimedia and simulations, challenges and mitigations, uh, cost and procurement phased pilot prioritize essentials and faculty skill gap. Short PD sprints plus co-teaching or instructional designer support and maintenance and downtime. So service contracts and simple low-tax fallbacks. Equity, device internet, loaner devices, mobile first contained, and offline downloads. So pilot one, a smart room with clear use cases, train faculty with 2-3 demo lessons, integrate with LMS and backup workflows, collect users metrics and user feedback, etc. So interactive displays plus AV for hybrid teaching, live polling and analytics for instant feedback, phased rollout, PD and low tech fallbacks. So e-resources and learning management systems, LMS. Why they are, yeah, or what they are. E-resources, e-books, journals, OER, videos, simulations, lecture captures, and LMS software that organizes courses, hosts content, run quizzes, tracks progress, and centralizes communication, just like a Moodle, Canvas, and Blackboard. Core LMS features course shells, document, and multimedia hosting gradebook, quizzes, assignments, rubrics, discussions forums, integration with plagiarism checklists or LTI, SCORM content, mobile apps plus analytics dashboards. So practical classroom uses central hub for flipped classrooms and weekly low stages quizzes plus automated peer review workflows and group submission, e-portfolios, centralized access and version control for course materials. So data for informing instruction, scalable communication and assessments. So usability and adoption, use intuitive LMS provide templates and short how-to videos, content load and discoverability and structured models, tagging and a course template, data privacy and vendor lock and check data policies, prefer open standards, regular backups and digital divide, downloadable PDFs, mobile compatible layout, and define essential LMS functions before selecting. Build a course template and a short onboarding module for students and staff. Integrate SSO and backup policies. Create a content governance plan who uploads and who updates. So central course hub, content quizzes, grades, forums, enables flipped blended learning and analytics. So require templates, onboarding, privacy policy. So if we talk about the online platform like MOOCs and Swayam Coursera, what they are: massive open online courses and national platforms offering structured courses, often with video lectures, readings, quizzes, and certificates. Examples: Coursera, Swayam, and Khan Academy. How they are commonly used in higher ed: curate models as pre-class or supplementary material, offer credit-bearing micro courses or certificate pathways. So faculty adopt content as readings or replace basic lectures with high quality MOOC videos. Access to high quality diverse content and international instructors, scalable professional development and student upskilling. Option for micro credentials and stackable certificates. Challenges and mitigations, just like low completion rates, run cohort based, just like it's based basically local study groups with deadlines and mentor support. Assessment integrity and credit recognition use proctored exams, institution specific assignments mapped to MOOC content and alignment with program outcomes. Curate and map only relevant models. Require reflective and transfer tasks. The cost for verified certificates, negotiate institutional licenses or subsidize for target students. Use MOOCs and SWAYAM courses as curated, scalable content. Blend with local coaching, proctored assessment, and reflective tasks. So run coherent support to improve completion and credit mapping. Quick integration checklist, one slide summary, and start with outcomes. Pick tech that evidences those outcomes. Pilot a small one classroom, collect metrics, engagement, quiz gains, and train faculty with micro PD and provide starter templates. Ensure accessibility and mobile first downloadable content. So pre-class and self-learning and in-class application. What is pre-class and self-learning? What and why? What? What is the pre-class self-learning? Short, focused learning activities in students do before class to acquire foundational knowledge, facts, concepts, terminology, etc. And why? Moves lower order learning, remember and understand, and outside class, so face-to-face time is used for higher order thinking, apply, analyze, create, increases class productivity and depth. Core components, clear learning objectives for the pre-class task, and by the time would be able to. And micro content, 5 to 15-minute video or short readings, a one-page summary, and guided worksheet, content map with focus on tricky ideas, low stakes accountability, short quiz, 3-5 MCQs or 1-minute paper submitted on LMS. So prep prompt reflection on open question students must post on a discussion board. What confused you most? What confused you most? Best practices: chunk content into very short pieces, level estimated time 10 minutes, and provide transcripts and captions and low bandwidth alternative. So give precise prep instructions, what to watch and which pages and what to submit. Use a quick and graded micro quiz to encourage completion and provide analytics. assessment and accountability. Auto-graded and pre-quiz for basic checks counts for a small or completion credit. Use forum post short reflections for qualitative evidence of preparation. Instructor views analytics to identify common misconceptions before class. So common pitfalls and mitigations, low completion rates, require short graded quiz, use reminders and make prep clearly tied to in a class task. So too much content, trim to essentials, link optional extension material. Accessibility issues always include transcripts, downloadable slides, and alternative readings. In class application discussion, problem solving, what and why. Active collaborative activities that use class time for applying concepts, solving authentic problems, and discussing misconceptions and producing evidence of learning. Why? Fosters deeper understanding, critical thinking, teamwork, and transfer of knowledge to real context, typical structure and activities. Quick entry, rapid quiz poll, or 1 minute paper should about prep class reviews, misconceptions, brief recap. Instructor clarifies common errors identified from pre-class analytics. Problem-based group work, solving a real scenario, case discussion, role play, simulation, jigsaw, and live demonstration plus student troubleshooting. Synthesis and reflection. Groups present conclusions, exit ticket, one key takeaway, and plus one question. Teacher role, what is it? Teacher and coach set clear tasks, provide scaffolds, circulate probing questions, summarize, and use probing questions to promote higher order thinking rather than giving answers. So, formative checks during activity or summative artifacts group report, recorded presentation, deliverable, or individual reflective journal. Peer and self-assessment can be used to evaluate collaboration. And 50-minute lesson plan. Just like 0 to 5 minute entry poll pre-quiz check and 5 to 8 minute instructor clarifies two main misconceptions, 8 to 10 minutes setup group task and rubric role assigned, 10 to 30 minute group problem solving teacher circulates TA supports, and 35 to 45 minute group presentations to three groups plus class question answer, 45 to 50 minute exit ticket plus assignment of follow-up. So mapping in to Bloom's taxonomy, pre-class, remember and understand, and in class, apply, analyze, evaluate, and create. So just like examples, if you concrete and engineering management, and especially that pre-class short video on circuit theory, plus quiz in class teams build and troubleshoot a simple circuit and submit function demo. Business pre-class case reading for guided questions in class jigsaw discussion to recommend strategy then peer critic, and language pre-class podcast episode plus vocab list in class role plays using new vocabulary and peer feedback. Implementation tips and tech, use LMS models to package pre-class materials and auto-grade quizzes. Polling tools to do quick chats, collaborative docs for group work, and breakout rooms for small groups, shared whiteboards for brainstorming, and rubrics shared in advance to so students know success criteria. A student leader model and include peer leaders to support groups in large classes. So, implementation tips and tech, use LMS models, polling tools, breakout rooms, rubrics, and TA student leader model. Challenges and solutions. Students don't prepare. Grading a small pre-class task require a relevant in-class activity that can't be done without preparation. So, uneven group contribution, assign roles, use peer evaluation and individual reflection. Time management in class. Set timers, give explicit milestones and deliverables, assessment alignment, ensuring class tasks directly map to learning outcomes and summative assessments. Slide ready, just like a pre-class self-learning, short micro-content, 5 to 15 minute plus clear objectives, guided worksheet, plus low-stakes quiz, forum post, and base knowledge reveals misconceptions pre-class. Quick entry check, clarify, and active group problem solving. Use PBL, jigsaw, simulations, when is with synthesis, and exit ticket. So focus class time on applying, analyzing, and creating. Visual idea, two-column timeline before class and during class. With icons for video, quiz, group, presentation, exit ticket, etc. So you want blended learning explain just like we can also explain about the blended learning. And blended learning is an instructional approach that combines traditional face-to-face classroom teaching with online learning methods. It allows learners to benefit from both in-person interaction and digital flexibility. Mix of classroom teaching plus online learning resources, learners get self-paced online study plus collaborative classroom activities. Technology used LMS, Moodle, Google Classrooms, videos, quizzes, simulations, forums. Teacher acts as facilitator and mentor rather than only a lecturer. So common models of blended learning, flipped classroom, rotation model, flex model, enriched virtual model, and students learn basic concepts online before class and apply knowledge in class through activities. So students rotate between online and offline activities. Online platform is the main learning mode with teacher support as needed. And enriched visual models, some lessons online with occasional face-to-face sessions. And there are some benefits also, just like flexibility, personalized learning, active learning, higher engagement, skill development. Flexibility, students can access content anytime and anywhere. Personalized learning, self-paced online learning with teacher support in class and classroom sessions used for discussions, projects, and problem solving. Higher engagement, multimedia makes learning interactive and skill development, improves digital literacy and critical thinking and collaboration. So, digital divide. Not all students have equal access to technology, teaching, learning. Educators need skills to design and manage blended classes. Time consuming, requires extra effort to prepare online and offline resources. Self-discipline needed, students must manage time and stay motivated. Best practices, start small and blend short online models with classroom teaching, provide clear learning objectives and instructions for both modes. Use interactive tools, track student progress using LMS analytics, ensure equal access to devices and internet, regular feedback to keep students engaged, and pre-class, in-class, or post-class. Pre-class online, watch a 10-minute lecture video on marketing strategies. There's attempt 5 quiz questions. In-class offline, group discussion on a real-world case study of a company's marketing campaign. Post-class online, submit a short reflection blog or participate in a discussion forum. So, blended learning basically is a student-centered approach that combines the strengths of online and face-to-face learning. When designed thoughtfully, it improves engagement, flexibility, and learning outcomes. So you want experimental learning, and experimental learning, just like experimental learning is a hands-on, activity-based learning approach where students gain knowledge and skills through direct experiences, reflection, and application. It goes beyond theory, allowing learners to learn by doing, and focuses on real-world experiences instead of only lectures. involves active participation by students. Learning cycle includes experience, reflection, conceptualization, and application. Encourages problem solving, critical thinking, and creativity. So, COP's experimental learning cycle, concrete experience, reflective observation, abstract conceptualization, and concrete experience doing a hands-on task. Example, just like a project experiment, role play. Reflective observation, thinking about what happened, just like a group discussion, journalizing. Abstract conceptualization, connecting experience to theory. It's like a linking to classroom and concepts. Active experimentation, applying learning in new situations, new project, case study. So there are some benefits, also improves deep understanding of concepts, builds practical skills, real world application, encourages teamwork, leadership, and problem solving, enhances student engagement and motivation. So fosters critical thinking and adaptability. There are some challenges also, just like requires more time, resources, and planning. Not all students may adapt quickly to activity-based learning. Difficult to access learning outcomes with traditional exams. Needs skilled facilitation by teachers. So examples in education is like a science, management, engineering, social sciences, and medicine and nursing. Performing lab experiments instead of just reading theory. In a management, business simulations, case studies, internships. In engineering, building prototypes, industry projects. In social science, role plays, community service, field work, or medicine and nursing, clinical rotations, and real patient interactions. So, experimental learning is a powerful student centered approach that connects theory to practice by engaging in real life activities, reflecting on them, and applying insights. Learners develop deeper knowledge and essential life skills. So, if you talk about project based learning, project based learning or PBL is an instructional approach where students learn by engaging in real world projects. Instead of passively listening to lectures, students actively explore, research, and create solutions to meaningful problems. So, key features, learning happens through projects, not just lessons, and encourages collaboration and teamwork. So, students develop 21st century skills, critical thinking, communication, problem solving, creativity, and projects are often interdisciplinary. Ends with a presentation or a tangible project product. PBL process steps is like a driving questions, inquiry and research, project work, collaboration and feedback. Driving question start with a real world, open-ended problem. How can we reduce plastic waste in our city? There are some practical questions or open-ended problems. So start with a real world and inquiry and research. Students research, collect data, brainstorm solutions, and project work, designing, creating, and testing solutions, collaboration and feedback, working in teams, receiving teacher and peer feedback. So, final presentation and product, showcase results, report prototype, exhibition, video, model, etc. Reflection and evaluation. The students analyze what they learned and how to improve. Benefits, makes learning engaging and meaningful, builds practical skills, research, teamwork, leadership, presentation, encourages self-directed learning, and connects classroom learning to real-world applications, and improves retention and deeper understanding. So there are some challenges, also requires time and planning. Assessment is more complex than traditional exams, needs active teacher facilitation. Some students may struggle with open-ended tasks, and just like there are some examples of PBL is science, engineering, management, social studies, and IT. Science, designing a low-cost water filter for rural areas, and engineering, building a solar-powered device, and in a management, creating a startup business plan. Social studies, community awareness campaign on health issues. and IT developing an educational app. So PBL is a student-centered inquiry-driven approach where learners gain knowledge and skills by working in authentic real-world projects, making educational practical, engaging, and impactful. So problem-based learning. Problem-based learning is a student-centered and teaching method. So learners gain knowledge and skills by working through real-world problems. So there are some examples also. So now we talk about the case study method. Case study method is a teaching approach in which students learn by analyzing real or simulated scenarios. It encourages learners to examine problems, evaluate options, and propose solutions, fostering practical decision-making skills. Based on real-life situations or practical examples, focuses on in-depth analysis of a single case and encourages active participation and discussion. Students act as problem solvers and decision makers. Teacher facilitates learning by guiding analysis and reflection. So there are some basic steps are present case, identify problems, analyze information, explore alternatives, decision making, and reflection. So, in a present case, provide a detailed scenario, business issue, medical case, social problem, etc., and identify problems. What are the key issues in the case? And analyze information, examine facts, figures, and context. Explore alternatives, brainstorm possible solutions or strategies. Decision making, choose the best possible solution with justification, and reflection, evaluate the learning outcomes and decisions taken. Yeah, some benefits are develops critical thinking and analytical skills, connects theory with real world application, enhances decision making and problem solving, promotes interactive learning through discussions, builds communication and presentation skills. There are some challenges also, time consuming preparation and discussion, requires well designed, relevant cases, and some students may stay passive in group discussions. Difficult to access individual contributions fairly. So, examples of case study, business studies, medical field, law, education, and environmental science. Analyzing why a company failed or succeeded. And medical field, diagnosing a patient based on case details. And law, studying a landmark court case to apply legal principles. Or education, examining classroom management issues, environmental science, case of water pollution in a city, etc. So gamification is the use of game elements and mechanisms such as points, badges, leaderboards, challenges, and rewards. In a non-game context like education to increase engagement, motivation, and learning outcomes, there are some key features are use game-like elements, points, badges, levels, rewards. So encourages competition and collaboration, provides instant feedback and progress tracking, focuses on fun plus learning edutainment. So motivates students through extrinsic and intrinsic rewards. Process on steps to apply in cases, just like in class, uh, set learning goals, choose game elements, create levels and stages, reward progress, and encourage collaboration, track, and reflect. Define what students should achieve and choose game elements, points, quizzes, challenges, leaderboards, badges, and create levels and stages. Break content into milestones. Reward and progress. Give recognition, stars, badges, certificates. Encourage collaboration, group tasks, team competitions, and track and reflect. So, progress and provide feedback. So, there are some benefits are like increase student engagement and motivation, makes learning interactive and enjoyable, encourages active participation, improves retention of concepts through practice, and develops problem solving, teamwork, and resilience. So there are some challenges require careful design to align with learning goals, and overemphasis on rewards may reduce intrinsic motivation. Some students may feel discouraged in competitive settings, needs digital tools a time investment for setup. So just like gamification transform the classrooms into a motivating game like environment where students learn by playing, competing, and collaborating, making education fun and full. So if you talk about simulation and role play, then simulation, a teaching method where learners experience a realistic situation or system in a controlled environment to practice decision making. Role play, a method where students act out roles in a scenario to understand perspectives, practice skills, or solve problems. Key features: active experiential learning, real life scenarios in a safe classroom environment, and develops critical thinking, empathy, and communication, encourages collaboration and problem solving, and allows trial and error without real world risk. So, define objective, design scenario, assign roles, enact simulation and role play, and debrief and reflect. What skills and knowledge should students gain? Create a realistic case, problem, or workplace setting. Students act as doctors, managers, customers, engineers, etc. So perform the activity, make decisions, solve challenges, discuss experiences, mistakes, and lessons learned. So increases student engagement, improves practical knowledge and application of theory, and enhances decision making and leadership skills, builds empathy and teamwork, provides safe environment to practice real world skills. And examples in education: medical students, business and management, negotiation and leadership, law education, and engineering. So practicing surgeries or patient diagnosis via simulation labs, role play as managers, employees, or clients to practice negotiation and leadership. So mock trials, count room simulations, safety drills, lab simulations, teacher training, role play as teacher and student to practice classroom management. So simulation and role play methods is the gap between theory and practice, preparing students for real life challenges through hands-on interactive experiences. So peer-to-peer learning, P2P, a collaborative learning approach where students teach, share knowledge, and support each other instead of relying only on the teacher. So students learn by teaching others, encourages mutual exchange of knowledge, and students act as both learners and teachers, focuses on collaboration over competition, and encourages active participation and accountability, builds a community of learners, just like identify topic and task and group peer students, peer teaching discussion, feedback exchange, and reflection. Teacher assigns a lesson, project, or problem. So divide class into small groups or pairs. Students explain concepts, solve problems, and clarify doubts for each other. So learners provide constructive feedback, and teacher guides and concludes with key insights. There are some benefits are just like a developed communication and leadership skills, improves understanding through teaching, and encourages teamwork and collaboration. So there are some challenges like possibility of misconceptions, spreading if peers give wrong information. Some students may dominate while shy ones remain silent. Needs teacher supervision to guide and correct learning, and time consuming in large classrooms. So examples in education just like a study buddy system. Students pair up to teach and explain topics. Peer review, reviewing and giving feedback on each other's assignments. And group discussions, collaborative problem solving, and coding boot camps. Students teaching each other programming, language learning, practicing conversation with peers. Some peer-to-peer learning in past, just like if you conclude this topic, then students should take ownership of their learning, making the classroom interactive, supportive, and collaborative, while teachers act as facilitators. So collaborative and cooperative learning. Collaborative learning, students work together in groups to solve problems, complete projects, or discuss concepts. Cooperative learning, a structured form of collaborative learning where students are assigned specific roles and work interdependently toward a shared goal. So there are some key features: group-based approach, shared responsibility, positive interdependence, and teacher as facilitator. Learning happens in teams, not individually. Each member contributes to group success, and students rely on one another to achieve outcomes. Guides and monitors group dynamics. So there are some steps and processes are task, problem assigned, forum and groups, role assignment, group interaction, presentation and reflection. Teacher sets a collaborative goal, and students divided into small diverse groups: leader, researcher, recorder, presenter, etc. Students discuss, brainstorm and solve. Groups present findings followed by reflection. So there are some benefits are: develops teamwork and communication skills, encourages peer support and mutual learning, enhances problem solving and critical thinking, and unequal participation, some may to do more, others less, and group conflicts or dominance issues, time management difficulties, requires teacher monitoring to ensure fairness. So just like examples in education, think, peer, share, jigsaw method, group projects, or collaborative writing, debates and discussions. The students first think individually, then pair up, and then share with class. And each students learn one part of a topic and teaches it to their group. So research presentations or lab experiments, teams co-create essays, reports, or digital content. Group argue, defend, and collaborate to group build perspectives. And design thinking in education. Design thinking is a human-centered problem-solving approach that encourages creativity, empathy, and innovation. In education, it equips students with the ability to identify problems, brainstorm solutions, and prototype ideas in a structured way. There are key stages just like empathize, define, ideate, prototype, and test. Understand learners or real-world users' needs through observation, interaction, and perspective taking. Define. Clearly state the problem or challenge based on insights, and ideate, brainstorm, and generate multiple possible solutions. Prototype: build simple models, drafts, or experiments to test ideas, try solutions in real world settings, gather feedback, and improve. So, okay, so way forward and recommendations: capacity building programs for teachers, infrastructure investment, student centered curriculum, and so conclusion, just like we can conclude that emphasis on lifelong learning, and that's all from my side. And thank you so much. Thanks to all team members of IoT Academy for giving me this opportunity. Thank you. Thank you so much. If you have any questions, then please ask.